All right, so hopefully you work these out on your own, and let's see if you got them right. So this first one is tangent tangent of A over secant of A equals sine of A. So we're going to pick the more complicated side. And really the only thing I can think of is turning everything into sines and cosines. So we actually did some of these in chapter 1. So tangent is sine of A over cosine of A. I draw, when you're doing this, notice you're going to have a fraction over a fraction. So I'm going to make the main fraction, the one in the middle, I'm going to make it bigger to make it really obvious to the reader what the numerator is and what the denominator is. And then for secant, secant is 1 over cosine. Excuse me. All right. So next, I'm going to multiply the top and bottom. Let me put it over here. By the denominator. Notice that they have the same denominator. So I'm going to multiply it by cosine A over 1, cosine A over 1. Now when you do that, notice the 1, 1 cancel, cosine A cancels, cosine cancels, and you're left with just sine of A. There you go. All right, now, if you wanted to break it down into more steps, you could. I'm already in want to get this done mode, so my brain's like, go to sleep, Gilbert. So if you multiply it through, then yeah, you'll see everything cancel. And then the only thing you're left with, since everything canceled out, is sine of A. I guess that's the more proper way to do it, showing every single step. Let's go to the next one. Sine squared t times cotangent squared t plus 1. So I'm going to do this two ways. The first way is, notice that cotangent squared plus 1 is an identity. Cotangent squared plus 1 is cosecant squared. So I just need to turn this into cosecant squared. But cosecant squared is 1 over sine squared. And notice that you get sine squared over sine squared. So those would cancel. And you're left with 1. Now, if you didn't notice the trig substitution, you could have just distributed. Actually, when I first did it, I didn't notice the trig substitution. So if you distribute, you would have sine squared t. Let me write the whole thing and not be lazy. And so if you ever wondered why I curl my t's, it's to differentiate between a t and a plus sign. I didn't curl it very well there. But it's a habit that you need to get into when you're doing proofs, because you don't want the plus sign to be confused with a t or vice versa. Anyway, so if we distribute, we have sine squared times cotangent squared. Plus sine squared. Remember, I'm not allowed to work on the 1. And we have sine squared of t. Cotangent is just cosine over sine squared. The sine squareds cancel. And we're left with cosine squared t plus sine squared t. And then again, that is going to give you 1. Okay, so I did it both ways. And either way is correct. That's why when we're doing these proofs, I'm going to be grading a lot of these, not the homework. All right, let's go to the next one. Here, the secant squared plus, or secant x plus cosecant x isn't an identity. So I think the easiest thing we could do is I'm going to choose this side, and let's start with it and let's work it out. So I have sine x, secant x, plus cosecant x. And I'm going to distribute. So I have sine x times secant x plus sine x times cosecant x. Sine x secant is just 1 over cosine. And I'm trying my best to line everything up. Cosecant is 1 over sine. And notice that you end up with sine of x over cosine of x plus sine of x over sine of x. And sine x over cosine is tangent of x. Sine x over sine x is 1. And again, what's the confusing part, if you go straight down, your lines tend to get a little crowded. That's the one bad thing about going down, but there you go. Meh, 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 meh. All right, so those are the easy ones. Let's go to the medium ones. I gave you a hint on this one, and I told you that 1 is the same thing as 1 to the 4th. So we're going to work with this side. Write it down. So 1 minus cosine of the 4th is going to be 1 minus cosine squared x, 1 plus cosine squared x. And here I have 1 plus cosine squared x. Now, happy things happen. Notice that the way I have it written, it's already, we have the 1 plus cosine and the 1 plus cosine simply cancel out. That leaves us with 1 minus cosine squared, which again, 1 minus cosine squared is just sine squared. That's it. So that proof was relatively easy. Just looks like one. Next one, secant b minus cosine b equals tangent times sine. Now I worked it out both ways over here. And after working it both ways, we found that doing the plus, or the add subtract side, was easier. So I'm going to work with this side. And so again, I'm using my previous experiences to dictate how I'm going to go about a proof. So if I have secant of b minus cosine of b, all right, secant is 1 over cosine b. I'm going to give myself some space. Cosine b. Now this is really over 1. And my goal is to get the common denominator. So really I'm going to multiply this side by 1 over 1, which doesn't do anything. But I'm going to multiply this side by cosine b over cosine b. When that happens, notice I end up with 1 over cosine of b minus cosine squared b over cosine b. And you may notice that the numerator already has that 1 minus cosine. So I have 1 minus cosine squared b over cosine b. 1 minus cosine squared, this is where the trig identity comes in, is sine squared. And then from there, you can kind of break it apart. I know my answer is tangent sine. So I'm going to have to break the sign into two terms, because that's what squared means. And there it is. Notice that these two is tangent. So I have sine B tangent. And notice the flow that I did here. I started going down, then I went to the side, which you have to put the equal sign. And then I started going down again, and then I went to the side again. So your flow, as long as I can follow your flow with my eyes and I can see what you're doing, I'm not going to be, get angry at you. But if your proof is all over the place, where one step is on one side and then the other step is on like way up here, then I'll get angry. All right. Secant to the fourth minus tangent to the fourth equals secant squared plus tangent squared. So I know that the fourth ones, I can break that down. So I'm going to start with this side. Hold on. My cat's doing something. What's she up to? All right, so I was looking at my notes, and just while looking at this, I realized that there's an easier way to do it. I'm going to do it both ways, though, to show you. So here, if I deal with it to the fourths, I have secant squared theta plus cosecant squared theta. Wait a minute. Sorry. Secant squared plus tangent squared theta. And then here I have secant squared theta minus tangent squared theta. And so here we have something unique happening. Notice that the answer I want is right here, and I already have it right here. So that means that I'm going to leave this alone. My goal now is to work on the other part. Now, every time I write a new step, I'm going to have to rewrite this side. But let me split up the secant and tangent into trig functions, or into their sines and cosines. That's squared. I can write that right. Tangent is sine squared over cosine squared. Here they have the same denominator. So I have 1 minus sine squared over cosine squared. But 1 minus sine squared is just cosine squared. Now you can't just say, oh, that those cancel and they're 1. You have to show the substitution. So now I have cosine squared theta over cosine squared theta. Those cancel. And now I'm left with my answer. So here's an example of, you work it out, you got it right, full credit. But you may have a friend that did it a different way, and it's completely possible. It turns out that this problem, I could have started with the other side. So again, that's one way to do it. The other way to do it, if I started with secant squared plus tangent squared, hold on, I need to check something. Actually, no. I was doing it in my head and I did something wrong, but I'm just going to work it out that one way. I apologize, but there are ways to do it. If you were doing it the other way, like if that's what you started with, notice if you multiply by the conjugate, So if you multiply these two, notice that you get the to the fourths that we see on the other side. And that's kind of what I got excited about, but the denominator, I was like, oh, denominator. And so if you do that, you end up with secant to the fourth theta minus tangent to the fourth theta over secant squared theta plus tangent squared theta. And so what you would notice is that you have the to the fourths, but you still have the same problem. Notice I had to prove secant squared minus tangent squared was 1. And here I run into the same dilemma. Yeah. Sorry. I'm just messing up right now. Gilbert, why are you being so confusing? I'm fixing a mistake I made. I was like, wait, that's not right. There you go. So we end up trying to prove the same thing. In the first proof, I had to prove secant squared minus tangent squared was 1. And if I do it the other way, I end up having to do the same thing. But both ways are valid. Anyway, so let's do the last two, and then we'll be done with this. So cosine of the fourth minus sine of the fourth equals 1 minus 2 sine squared. So here, I'm going to start with this side, just because it's something I'm familiar with. I know this is going to be cosine squared A plus sine squared A, cosine squared A minus sine squared A. But we notice that we have an identity. That is just going to be 1. Okay? And so now, how do we prove that cosine squared minus sine squared is 1 minus 2 sine squared A? Well, notice that they both have the sine squareds. We look and we notice that that's there. So I'm probably going to want to leave alone. Maybe, because I already have my sine squared. So anything I do, I would probably want to do to cosine squared. Really, the only thing I can think of is cosine squared becomes 1 minus sine squared. So I'm doing another trig substitution. Cosine squared is the same thing as 1 minus sine, and notice that's where you get the 2 from. I have minus sine squared minus sine squared, so 1 minus 2 sine squared. Okay. Yay! So that one was actually not that bad. But now we get to go to the ugly one. This is the fun one. So hopefully you tried this on your own. What I'm going to do is I'm going to work on the more complicated side. So this nasty thing. So let's do it. Hopefully I'll be able to fit it on this page. And I have cosine x minus 2 cosine cubed x. So the first thing I notice is I can factor things out. On the top, they both have a sign in common. So if I factor the sine of x out, I'm left with 1 sine of x left plus cosine of x. On the bottom, I can factor a cosine of x out, and that leaves me with 1 minus 2 sine squared of x. So one thing to notice is tangent, and there's my tangent. So I'm going to probably leave that sine and cosine alone, because I already know those turn into tangent. So I have tangent of x, sine of x plus cosine of x. 1 minus 2 sine squared of x. All right, so what can I do? What can I do? What can I do? Well, notice I have, oh, why did I say sine? What am I doing? Guys, oh, you can't really call me on it if you're watching this later. I apologize. I make silly mistakes. Anyway, if you wanted to be really fancy, you can use what we learned above to kind of work this out. Notice that 1 minus 2 sine squared a was cosine of the 4 minus sine of the 4. But that's stretching it a bit. There's a similar formula for cosine instead of sine. But really all I could think of, and this is where we break the mold a bit. I worked on this before I did the lecture, so I know what to do. But what I want to do is I want to get sine x minus cosine x in the denominator. And notice that that's conveniently the conjugate of sine x plus cosine x. So I'm just going to add it to the denominator myself. Now I rewrite everything. Tangent of x. I can multiply these two now because those are conjugates. And so that's going to be sine squared x minus cosine squared x. On the bottom, I'm going to leave that alone. I know I have 1 minus 2 cosine squared x sine x minus cosine x. And so my answer is kind of there. I just have to get rid of things. And this is where we're going to do a rule backwards. That 1, and again, taking from what we learned up here. But I'm going backwards. So I have the 1 is sine squared of x plus cosine squared of x minus, okay, let's try to make sure everything works out. So cosine squared minus 2 cosine squared. Right. I'm being lazy. Sorry, they're showing South Park on the TV and I'm trying to do both at the same time. And I'm not a good multitasker. It's not what I do. Okay, I forgot to rewrite the whole problem. And so notice we have cosine minus 2 cosine. And those can combine, which is going to eventually make the cancellation that I need. So let me hide everything from over here so I can have the room I need. Okay, sorry. So rewriting the whole problem again. So those cancel out, And I'm left with my answer, which is tangent of x over sine x minus cosine x. So those are some of the toughies. You'll get problems that you're like, wow, okay, I would have never thought of that. All right. So, yeah, let me know if you have any questions. There was something more I want to say, so let me think about that for a bit. Let me pause. No, it was nothing important. Anyway, let me know if you have any questions. And again, sorry for being distracted for a little bit. Bad Gilbert for trying to multitask. Anyway, have a good day.